let's talk about the side splitter theorem. A fun name for a fun topic. So it has to do with triangles and its sides being split. So let's take a look. Let's get the definition. Let's get this theorem down and bring up a picture. So this is the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So the line that we're speaking of is this line here. It is parallel to the base of my triangle. Check. And then it intersects the other two sides at this point and this point. So if that is true, then we can set up a proportion. And that proportion is going to be segment A over segment B equals segment C over segment D. That's very important that you get this triangle down labeled correctly and then this proportion down. A is to B as C is to D. And using this idea, we can solve a lot of problems that deal with triangles if we're missing A, B, C, or D. And this can be proven, which is not the point of this video today, so we're not going to go through the whole proof. But it can be proven with the idea of similar triangles because this smaller triangle is similar to the larger triangle. And that can be proven with the AA postulate. Using that and the idea of segment addition, we can get to this proportion. Again, I'm not going to go through the whole proof, so basically you just need to have this part memorized for the side splitter theorem. Now let's use this idea to go ahead and do some problems. Okay, here's problem number 1. So go ahead and draw that triangle. Label this first segment AP as X, this segment 16, this segment 5, and this segment 10. Just like I have here. You don't necessarily have to worry about the names of these points. Okay, so according to my side splitter theorem, I can write a proportion by looking at just this left side and writing X over 16 equals, now looking at the right side, this segment over this segment, 5 over 10. Pretty simple. So here the left side, X over 16 equals 5 over 10, and it'll follow that pattern every time. Then to solve this proportion, just simply cross multiply. X times 10 is 10x equals 16 times 5, which is 80. Divide both sides by 10, and we get X, that missing segment in this triangle is 8. So this part here is 8. So that's how you use this side splitter theorem to solve for a missing segment of my triangle. Let's do another example like this. So number 2, again, draw your triangle, label these segments 12, X, 16, and 4. Okay, set up your proportion. Again, looking at that left side, 12 over X equals, look at the right side, 16 over 4. Then I cross multiply. X times 16 is 16x. I always start with the two that include the x equals, and then multiply the other two together, 12 times 4, which is 48. Divide both sides by 16. X equals 3. So this missing segment here is 3. So let's do one where the algebra is a little bit harder. Right, number 3. The segments on the left side, x plus 10 and x, and the segments on the right side, 5 and 3. All right, let's set up our proportions just like before. X plus 10 over x equals 5 over 3. Now cross multiply is going to be a little tricky. 5 times x, that's easy, it's just 5x, equals, here you must be careful, it is 3 times this quantity, x plus 10. So I'm just going to write it like that to start. This x plus 10 is grouped together with my parentheses because that whole numerator is x plus 10. Now to solve this problem, my first step is going to be to distribute the 3 to both the x and the 10. I'm going to bring down that 5x, bring down that equal sign. When I distribute, that means multiplication. 3 times x is 3x. 3 times 10 is 30. I have x's on both sides, so I'm going to fix that by subtracting that 3x from both sides to move it over to the left. 5x minus 3x is 2x. Bring down my equal sign, bring down 30. Divide both sides by 2. X equals 15. So that means that this section is 15. This section is 15 plus 10, which is 25. Okay, we can go a little farther with the side splitter theorem and look at some parallel lines cut by 2 transversals. So this is taking the side splitter theorem to a whole nother level, and instead of splitting sides of triangles, we're splitting these transversals. It's the same idea, and if I were to extend these transversals, they would cross and form a triangle. You can kind of see that triangle starting to be formed. Let's go ahead and copy this down, and then we're going to label this segment A, this segment B, this segment C, and then this segment D. And this is the same idea as the side splitting theorem for our triangles. So A over B on that left side equals C over D on that right side. So we're going to do some problems involving these transversals being split instead of the sides of our triangles being split. All right, so number 1. So on the left we have 8 and 6, and on the right 10 and x are segments, and it's the same idea as our triangles. It'll be 8 over 6 equals, on the right side, 10 over x. And then just like before, to solve this, cross multiply. So 8x is 8 times x is 8x equals 6 times 10, which is 60. Divide both sides by 8. X equals 7.5. And that's your answer. So let's do one more like this. All right, number 2, go ahead and copy that picture down. Set up your proportion using the segments on the left side, x over 20 equals the second ratio, using the numbers on that right side, 9 over 15. Cross multiply. X times 15 is 15x equals 20 times 9 is 180. Divide both sides by 15. X equals 12. So that missing segment is 12. So hopefully that made sense, how to find missing segments using the side splitter theorem for a triangle and then for some parallel lines.